All right, here we go. Time that we get ready. After a few minutes of sorting out the tech issues, let's start with our Space Talk, which might be the second one of 2024. If you've attended the first one, you know what it's about, but to all our newcomers, also to all the people that are joining us online on YouTube today, welcome to our series of Hardware Space Talks, where we invite guests, friends, partners, like Carlos Escapa, who takes the time to come here and share his knowledge, his insights, and his personal suggestions, his personal take on topics that we believe are pretty eminent. And obviously everyone's talking about AI these days, and I'm getting to a point where I'm having like too many AI talks. But when I met Carlos, he was able to tell me and show me a bit of a different approach, and that's why I'm actually very excited to have him here today. He's going to tell you more about who he is, where he works. Let's give him a warm welcome.
Online we need it actually. Oh, okay. We need it online. Okay, good morning, everybody. My name is Carlos Escapa. I work at Amazon Web Service, and I am a what's known as a data and AI a practice lead. So I develop the practice globally. I work a lot with partners, mostly with partners, but I also participate in a couple of programs at Amazon called Culture of Innovation and Learning from Amazon. So I speak a lot about how to innovate, collaborating with Amazon. So a lot of what I will tell you this morning is going to be anchored on use cases, on ways that we use data to solve problems. It's going to be interesting coordinating the two gizmos in one hand. Okay, so basically what I do, I work here, mostly in technology. I work on implementations, on real use cases. Obviously, I keep an eye on research to see what is happening, because this line is moving very quickly. As you know, the difference between science and technology is actually sometimes it can take 10, 20, 30 years from a development in science to actually make its way to the real world. But something that we have learned, we as in humanity has learned, is to move scientific concepts into engineering significantly faster than in the past. And particularly because so much of what we do is digitized, is actually getting easier and easier to do it. And this is actually creating, at the same time, a lot more business opportunities for young people like you to create new companies. It is also a little bit harder to live in the world, a world where people were used to maybe learning for 5, 10, 15 years and then do the same thing the rest of their lives to earn their living. That is basically less and less accessible. Our careers have to evolve very quickly, precisely for this reason, because science makes its way to technology. There is a line there between research and science fiction. In this area that is called artificial intelligence, that hasn't moved for 40 years. Believe it or not. The techniques that we use to develop what are known as machine learning models, which are the core components of artificial intelligence, rely on a technique called Bayesian, well, it's actually Bayes' theorem. How many people are familiar with it? About half of you. It's a mathematical technique that dates back to the 19th century. And what we do is basically apply more and more data, more and more computational capability, but we're basically using and reusing and using again Bayes' theorem. I think he would be very proud of himself if he knew how dependent we have become on that theorem. The point here, and we lost the slides, is that the concept of artificial intelligence was actually coined back in 1955 as a summer research project, and the name stuck. And it is incorrect. The name is incorrect. There's no intelligence per se in artificial intelligence. There's nothing related to cognitive services, cognitive processes that replicate what we do in the mind. It gives that impression, but there's nothing intelligent about what we do. And we lost, let me see if we can get it back. Okay, good, all right. However, this field attracts a lot of people who like to communicate about it, who basically get in front of it. They like to get in front of cameras. They like to publicize what they do. And frankly, I think we have to admit, those of us who are practitioners, that we're not very good about communicating what we do. And not only that, we like the mysticism that these machines that we create have generated, because it attracts money, it attracts prestige, and I guess we're all human at the end of the day. But it is important to understand this, and I will get to that, because there's entire areas around risk management, for instance, law, that apply when you use machine learning. But let me ground the conversation here about on what is going on, right? This is a page from Amazon.com in 1999, I believe it is. And this is where you see the beginnings of what is called today artificial intelligence. Back then, this was just simply a recommendation engine. That's what we knew it as. And what we do here is we provide recommendations to customers as to what kind of books they may be interested in, right? This is surprisingly easy to do. We're looking here for correlations. We're looking for a cohort of people who buy similar books with similar titles, with similar authors, and we use a technique called collaborative filtering in order to provide these recommendations to customers. And we were actually really surprised at how effective these recommendations were. In fact, consumer behavior is surprisingly predictable. And this actually is helped propel the growth, the early growth of Amazon.com by doing these techniques that are basically linear regressions, if you are mathematically inclined. Extremely simple. To me, it's ridiculous that we call this today artificial intelligence, but hype is a problem in the world, and AI has a big hype problem. Today, in Amazon.com, actually, we generate predictions for the number of products that are going to be ordered every single day for 400 million products in approximately 200,000 postal codes around the world. So this is, if you will, the evolution of that early recommendation engine. And this is what allows us now to automate the supply chain, because from the number of pencils that are going to be ordered in postal code 08018, what is the one here? Yeah. 08005. Oh, 005, okay. Then from there, actually, an entire set of actions actually take place up the supply chain. Like how many people are going to be available to deliver products, those pencils. How many pencils do we need to have on the closest depot? Then from there, where are those pencils going to be ordered from? From a fulfillment center. The trucks or whatever method of transportation goes, all the way up to ordering those products from the supplier. And as you can imagine, we do this well in advance, right? We have to predict seasonal products, okay? New products that appear for the first time in the market. And all of that, we do it in order to fulfill a promise to a customer that they're going to have that product available within 24 hours or 48 hours. But this actually has a very big wave of repercussion, if you will, all the way out to China or Turkey or Morocco or wherever the product is actually made. We now are looking at optimizing that last mile delivery, and this is a very interesting way that artificial intelligence is actually getting into the supply chain. Are you all familiar with this company, Rivian? Yeah? They make electric vehicles. So we actually have ordered 100,000 of these vehicles. They're delivery vans. What's interesting is that all of these vehicles have the same base. They call it the skateboard design. So the motricity of the vehicle, evidently the batteries, but more importantly, the processors and the buses are standard for all of the vehicles that we produce. And then we, as a customer of Rivian, ask them to provide a set of features for us. For instance, we want to know the temperature inside of the cabin because we want to use it for grocery delivery, right? And we want to be able to maintain a freshness and make sure that the product is never more than X minutes, not in a refrigerated area. So this is something that we can now accomplish. So all of this telemetry is actually relayed to this base, and then it is reported to us. It's not delivered necessarily in real time, because doing it in real time is evidently costly. There are some events that we want to learn in real time. For instance, if the airbag is deployed, that raises an alert. That's an immediate alert. But otherwise, we are collecting telemetry every 15 to 30 minutes, and that telemetry helps us to find the best route in order to deliver the packages to customers. In the past year, by the way, we have reduced the displacement, the number of kilometers that the vans do on any given day by 15 kilometers in the past year. Evidently, that helps us with not only the efficiency, but also with CO2 emissions quite significantly. There's emissions on electric vehicles as well, so I'm sure you know that, right? Yeah. Low carbon doesn't mean no carbon, very clearly. We have 750,000 robots, well, as of November of last year in Amazon.com. These robots are typically single task, the vast majority of them. There's nothing intelligent about it. They use models, they use so-called artificial intelligence, but if you try to do something with a robot that has not been designed to do, it will fail. Okay, these machines are not intelligent. They are meant, as you can see, they have a very funny design, right? So they have a very specific task inside of the data warehouses. This is one of our experimental warehouses. These robots here are not very big, and they're super strong. They lift and carry. They lift just a little bit, like 2 centimeters off the ground, and they carry the products, well, the boxes around inside of our warehouses. And these all move electronically. You know, the supply chain predictions that we make, they also determine the position of the products inside of a warehouse. So actually, they get moved all the time in order to reduce the number of meters that they have to travel when an order arrives. And all of that to make customers happy. That is what we do. Okay, fast forward now. And since we only have half an hour, I'm trying to keep a rhythm here. Well, generative artificial intelligence is all the rage at the moment, right? I'm sure that you have all been hearing about it in the past year. This is an example of an application that we deployed for the city of Washington, D.C. It is the health department. You will find that most public sector bodies, in fact, most companies, they have websites that map into the organization. And then each department updates the website without checking with other departments. This is typically the case. So these websites are not built for the citizens or for the end users. They're actually built for the comfort of the organization, typically what happens. So in this case, this website has 260 pages. And finding information in it is super, super difficult. Super difficult. What they asked us, they challenged us actually, hey, can we use generative AI in order to improve the ability for citizens to get information? And the answer is yes. The answer is yes. We use a technique here called Retrieval Augmented Generation, or RAG. Have you heard of it? Yeah. Spanish people pronounce it RAG. And what it does is it scans all the pages and then breaks each of the pages into little chunks. They're called, this is a technique in English called chunking. And then each of those chunks is converted into a list of numbers. We call that a vector. These numbers are between 0 and 1. And these vectors is what allow us to understand, to have a layer of semantics on these pages. And then we can take a query from a citizen. In this case, well, the chatbot is available in English and Spanish. And then the citizen can express a question. This question also is vectorized. Is there a way to prevent the...
It's in your settings of the laptop.
Oh, it is?
Yeah.
Okay. All right. It will happen once or twice more, but after that we will wrap. We vectorize this as well, and then we do a similarity search. The similarity search is a very sophisticated way for saying the cosine similarity. Okay, since these are vectors, numbers, it's basically instead of 3 dimensions, we have 1,500 dimensions in this particular implementation. But all we're doing here is just calculating the cosine and then finding which are those chunks that are closest to the question. That's what we pass to a large language model. It's a model called Claude. It's made by a company called Anthropic. And that model is the one that generates the response in prose, in regular language. And this is what allows us to do, for instance, in this particular case, the word pregnant used in Spanish is encinta, but actually the synonym is embarazo. So this is the kind of thing that can be very easily found. So you no longer rely on keywords. You actually are closer to interacting with the user in understanding the meaning. And synonyms work really well with this. It goes far beyond synonyms, by the way. One of the surprising things about generative AI is not so much the models or the mathematics. What we have learned is that there is a massive amount of structure in the human language. And this is something that we still have a long ways to go before we understand exactly what is going on, because it has really surprised us to see so much structure. I'll go with another example. This is in the UK, the Department of Work and Pensions. This ministry handles basically the welfare state of the UK. So in addition to taking care of pensions, people who have retired, they also administer unemployment and also anybody in society who needs assistance, from orphans to widowers to, well, everything else, basically. This department receives 25,000 letters from people per day, 8 million per year. Yeah, 8 million per year. That works out to about 25,000 per day. That's an average. Okay? Sometimes they have 10, sometimes they have 50,000. And they have a lot more, particularly during the autumn and the beginning of winter. Okay? And people ask for help. Yes, sorry?
Letters, not emails.
Correct. Letters, physical letters, and not forms. This is what is known as white mail. Letters like this. Dear Jane, my name is James, and in a few weeks I will be 80, and I'm in trouble with my health. Okay? These are people who are basically asking for help. About 10% of the letters require immediate attention. You can imagine that governments are relatively slow in handling this kind of interaction. So it could easily be 4 or 5 weeks before citizens get attention, and actually, in many cases, they need immediate attention. So the challenge here was, what can we do to improve the way that we handle these mails? This is what a solution looks like. It's kind of confusing, so yeah. But for those of you that are technical, this is a collection of finite state machines. Okay? It's just that there's a lot of components that come together. These are very, very flexible architectures, by the way. They can scale up and down. You can instantiate resources very easily in order to cope with the fact that you have peaks and troughs. So you don't have to have an infrastructure dimension for your top day of the year. You actually can grow and contract as you go along. But just to simplify things, there's a process where to ingest the letters, you have to open the letters physically and then scan them. You have to separate each of the pages, and then we make the machine readable using text extraction. And it works quite well, even with handwritten letters. Then we have to detect the language. Now, there's something very interesting that a lot of people don't realize, but how many official languages are there in the UK? Yeah, official languages. Who said two? Exactly. Exactly. Welsh and English are the two official languages. Okay? So the large language models that we have, they support English extremely well. Not so full of Welsh. So we have to detect the language. If it is Welsh, then we have to send it to a manual process. That is not automatable. Not today, at least. Then we find if there's any personal information in these letters, we remove it. Okay? It's just a way to avoid leakage of information if somebody makes a mistake or if there's a process downstream. Because at that point, we don't need to know the name of the person in order to determine the criticity of their situation. And then this innocuous-looking box here on the top right has two neural networks. One of them summarizes the letter, basically compresses the letter to make it richer semantically. And then the second one is a classifier. The classifier, if the letter corresponds to a person in urgent need, it will actually classify the need. In the case of the UK government, they have 15 categories for extreme need. Like at the top, as you might imagine, people with suicidal thoughts. Okay, those are the ones that have to be prioritized. But well, I mean, everything is a priority in these 15. Yeah, because you're talking about people maybe who become widow and they cannot take care of themselves. You have people who have been threatened to, or they haven't been able to pay the rent, and they're going to lose their home. And so on, it's those kind of cases. So based on that, then that goes immediately, it is routed into a mailbox for each of those categories where there is a case officer that then sends that over to a public servant that is in the vicinity of the person who has sent a letter, and then they try to contact them, and in many cases they actually go and see them because there are people that do not necessarily even have money to own a mobile phone. It's, we're talking about the most vulnerable members of society. There is, as always, some reporting to do in order to keep the senior management informed about what is happening. And if you will, the magic here to manage the workload is actually a queuing mechanism. This is actually what does the magic of increasing or decreasing the amount of infrastructure needed in order to expedite the processing of the letters. So this is, if you will, a real use case. Artificial intelligence in double quotes, here, here, and here. There is 4 models that are being used. Yes?
You mentioned that the model is not good in Wales language?
Correct.
Why don't you add like a layer of translation from Wales to English?
Why we do not add a layer of translation? It's not reliable enough. Yeah. Also, I think that the volume is not that high, so I will speculate that the customer told us that they prefer just to leave it with the existing manual process. Yeah, contrary to what you may have been told, actually, the precision of the language models varies enormously from language to language. And that's why there's governments around the world, actually, that are engaged in very high-speed development projects in order to provide a corpus of language data that is known as training data. For instance, the government of Singapore has collected Bahasa Indonesian, Malay, Vietnamese, and Tagalog in order to develop a model that will work well in ASEAN. Translation with even English to Japanese is not great.
But also, because Japanese is really bad at tokenizing, right? Like the tokenizers that we use in English don't work well in Japanese because of the structure of the language.
Exactly. Okay. Now you're a little technical. You understand this. Okay. Yeah. What is your name?
Amir.
Anir? Okay. Anir is talking, you mentioned a concept called tokenization. Okay. Tokenizing refers to the fact that you take basically encoded letters and concepts. There is a universal standard for encoding a machine-readable language, and then you break it into pieces. Those are the pieces that you convert into a vector, and then you go through this excruciating task of fitting a model to the text. If you do it in English, basically, well, actually, most of the models, not most, I think all of the models developed today, except perhaps some in China, I don't know, are based on the English language. And with the model also comes a point of view about history, about geography, about politics, about sociology, all of that. I mean, these models have a very strong Western bias, within that strong Anglo-Saxon bias, and within that a very strong American, like United States bias. It's something to be aware of. How much longer do we have?
10 minutes or so.
Oh, we still have 10 minutes, okay.
I mean, for the talk, 5 minutes.
Okay, terrific. Okay, I want to give you a couple of, just a couple of concepts here. When we talk about human intelligence, we are talking about a lot of different things. And we don't have consensus on what this means, but we certainly have an ability to learn, to infer, which is to come to conclusions from what we learn, and then we can reason. We have a sense of causality. We see phenomena happen in a time dimension and then understand that they are connected, that one actually is followed always by another, right? This is a very important thing that is something that we do every single day, every single moment almost of our life. We have a consciousness and an identity. This, again, it's not a concept that you can define scientifically. Something that we have, but we can't really define it. And then we have all of this around emotional intelligence, a very interesting subject, but we'll move on faster. With artificial intelligence, all we have is learning and inferencing. And it's a very limited way of learning. But we're actually, excuse me. We are learning mathematically. And because so much of what we have in the world has been digitized, this allows us actually to extend this learning in many different areas. And as the world is more and more digitized, actually there's more and more areas where we can apply this ability to learn and to infer. But machine learning models, again, the core components of artificial intelligence, do not reason, do not understand causality, do not have any consciousness. And not only that, there is absolutely no path to this. So there's a lot of people with conjectures about the fact that, oh, we're going to get better next year or the year after that and so on. But scientifically, you have to have a path to it. You cannot just simply bullshit your way through, which is a very typical thing to do these days in many areas. So there's no foundational aspect of research and scientific discovery that is charting a path towards reasoning or the concept of causality. And you will see people saying, actually advertising, that their models do reasoning. And actually all they're doing is predicting the next word in a sentence. There's nothing inherent to the understanding of a cause and effect. And this is something that we miscommunicate all of the time. And I think that a lot of people are confused, including politicians, very senior decision makers, CEOs of companies, and what have you. What we do in AI is sometimes surprising or wondrous because people don't expect or did not expect to be able to do what we do, and it looks like something that the brain does. But it couldn't be more different. And what's important to understand is that everything we do is finding correlations in the data. There is no concept of causality in artificial intelligence. And this is a very important point to understand, because if you go out to resolve a problem and you need causal analysis, then you should not use machine learning or AI in order to find a solution. You can use it to guide you towards a solution, but you're still going to have to understand the cause and effect relationship. Now, luckily, there's many, many problems that we can solve through correlation, like we do in Amazon, right? Because for the logistics, you don't really need to understand why people go to see Barbie and they order pink underwear. They just do, right? So having a supply chain optimized with correlations is perfectly fine. Whereas if you are a judge or a doctor or a lawyer, you more often than not have to understand causal relationship between, well, whatever, between laws and behavior of people and what have you. Okay, 2 examples of startups, and I will wrap up because I thought that this would be interesting. Okay, a couple of use cases. These are companies that have been created with machine learning models. Bolte actually is a Singaporean company. They took a model that actually was developed by Meta, a machine learning model that runs very happily inside of a telephone, relatively small. And then using the camera of the telephone, it can examine the screen of the phone by using a mirror. So you actually can download this application, you put it in front of a mirror, and then if the screen is not damaged, then Bolte actually issues a quote for insurance right there on the spot. This company went from 0 to having a prototype in 6 weeks, and a few months later they raised, I think I have it here, $200 million, like this. Super, super fast. Very, very successful project. Yeah, they are from Singapore. They actually did the development in Melbourne. They actually subcontracted the development. Yeah, and this is just somebody that saw an open source model come to market, and they had the idea, maybe we can use it for this. The market fit was excellent. And, well, the rest is history, as they say. Okay, this is in Norway. And this is a project that started with the automation of the milking machines throughout the Country. Tina is a cooperative. They have about 10,000 farms. So they started to collect the information from the milking machines. They could measure the amount of grass content in the milk day by day, and then they could determine whether the milk was better for drinking, or for butter, or for ice cream, or for yogurt, or whatever. Each of those actually run a different supply chain. So now they have information about each cow individually. They manage each cow, the output of each cow, and that informs also the supply. Not only that, I mean, this project went so well that Tina actually spun off their data science unit into a different company. If you want to look it up, it's called Mimiro, M-I-M-I-R-O. And actually, they're now collaborating with other cooperatives around the world in order to have a common data model in order to exchange the information through the supply chain. This is now we're going to Tel Aviv in Israel. The concept here is that the easiest way to explain it is think about this as a GoPro for surgeons. So the camera is actually looking at what the surgeon is doing, and then it actually generates a medical report automatically. So moment by moment, it actually understands where, for instance, it generates a report saying abdominal incision, 35 millimeters. After opening, it found an obstruction here or there, and it actually generates the report for the surgeon. So this actually saves the surgeon a lot of time after the surgery. And I have a few more examples, but I think I'm going to run out of time.
Let's see. If there is no many questions, then maybe we can continue with examples. But we also want to give the chance to our audience here as well as online to ask questions for Carlos particularly, now that we have a few minutes left before people need to break off and before we reach the end. And he already had a chance for a question. Anyone else maybe before him? Yes.
Thanks. Yeah, thanks for the talk. Very, very interesting. So you talked about hype there is another hype topic, which is like, oh, we will lose all the jobs to AI. I just wanted to ask you about your perspective, both from Amazon, but also personally. Like, do you think this is going to be this new wave? You know, we had automation waves before in the history, where like jobs got replaced, but we got more jobs. Do you think the same thing is going to happen? And if you think so, like what kind of new jobs do you expect to appear? Maybe you can share some insights from Amazon's point of view.
Yes, sure. There is definitely a lot of new jobs appearing in the marketplace. I just put one here because it's a very interesting question. Given the fact that you build models, I mean, let's be clear, okay? Machine learning models are data products. It's a little bit like, I don't know, gasoline is derived from oil, it's the same thing. You actually have raw data, and then when you order the data, when you find patterns in the data, then basically have a machine learning model. But this kind of job is actually appearing all over the place. So chief data officer, vice president of data, and so on, these are people who understand the corporate data in context. It's not just zeros and ones, they actually understand how to get the most value from the data. So this is just an example that the entire area of data science, the ability to understand data and also to come up with internal data products inside of the company is how a lot of value is being generated. So that's a source of jobs. With regard to your first question, I do not know. I do not know. I think I would be presumptuous if I told you that, oh, yes, this is going to be better. The thing is, in every wave of new machines arriving to the labor market since the steam engine, this has been an issue. Okay? In the 19th century, there was actually a group of people called Luddites who went around breaking engines because they were afraid of them, right? So you see it in every single step, and we somehow survive. So I'm very optimistic about our ability to survive. Now, I'm going to tell you something else. We have a rapidly aging population in the world. I'm going to tell you, in some places, like in Japan, they cannot mechanize and automate fast enough. They're really, really at the forefront, if you will, of adoption, because they have such a strong need to automate a lot of the functions in society. So I think that is going to be such a strong requirement that I don't think we have enough yet artificial intelligence in order to adapt rapidly to the aging population. Good question. Very good question.
So when you were presenting this project for a governmental thing in the US, that you said that you were using RAG and you were using Cloud API, I guess, for the predictions. My question was, are you also using the embeddings from for Cloud? Like, so to get the vectors, are you using the embeddings model from Cloud, or you're using, for example, OpenAI or something? And also, why Cloud and not OpenAI or something else, or something open source?
Sure. So this is a little bit technical, so the answer is yes, we use embeddings. You always use embeddings when you use a large language model. The embeddings model that we're using here is called Amazon Titan, Titan. Why we don't use OpenAI? Because it's not the only company in the world, and I know that everybody is transfixed by ChatGPT, but for instance, I use Perplexity.ai a lot. To me, that works a lot better when I am researching a given topic or I'm trying to get answers. Sorry?
Is one of the big models behind Perplexity? Could be either OpenAI or Bolte, maybe, I don't remember.
It's Claude.
Some of them.
For Perplexity, they use Claude in order to generate the responses. Yeah. Now, with regard to the embeddings, I'm not really sure. That is proprietary information, but they're obviously doing a very good job at indexing and generating composing the responses. Yeah. But given that we use statistical methods, you know, the embeddings is a way to translate words into numbers. Okay, we use statistical methods for that, and this is why sometimes these methods fail. and this is what is called a hallucination, which actually perpetuates this tendency that we have to render what we do in anthropological terms, and it's actually incorrect. It is a spurious correlation, actually, but we say hallucination because it comes as words. So that is a consequence of using statistical methods. There's no escaping that. Yep.
At the start of your talk, you touched briefly on robotics, and I was curious because there are a lot of startups currently that are trying to implement large language models together with robotics to make the robots appear smarter. And you mentioned that they have no real reasoning ability. So how far do you think we will be able to push large language models in robotics to kind of emulate that reasoning ability so that it seems that robots are smarter? How far do you think that can go?
Thank you. The answer is not far enough. Yeah. I mean, I don't think I will ever agree to work near a robot. So I'll be as clear as that. Since the transformer architecture, which actually have you heard of transformers? It's the architecture that underpins the large language models. That has evolved very rapidly. Well, and when I say very rapidly, it's been 6 years, so it wasn't overnight, okay? But in robotics, we haven't really improved a whole heck of a lot in the same time, yeah? Large language models are not going to make robotics any better or easier. You can make a robot talk, okay? But it's just talking. That's all it is doing. We know very well that children learn far more from experimentation and from visual stimulation than from words. So the idea that you can arrive at general intelligence through text is preposterous. It is part of the mythology that we have in the industry. So there is a very clear limit here, limiting factor when a model or a robot cannot experiment and learn from the experimentation. It is going to be limited in the things that it can do when it is programmed. Then the language can help to process interactions with other humans, with humans, for instance. But it is not going to teach robots to do new things. And be careful, there was a robot that broke a kid's finger in Moscow last year playing chess. The kid moved the pawn and then regretted the move and tried to move it back, and by then the robot actually was trying to take the pawn out of the chessboard and actually broke the kid's finger, right? This is a typical example of the kinds of things that can happen because these machines are not intelligent. Yes.
But as we see the big models evolving towards multimodal, like there are Gemini, GPT-4 with vision, these different modalities of words and vision are converging. And given that, what is the strategy of Amazon? You mentioned that you prefer now, at least for now, the single task robots. Moving forward, do you think that could change, that you would have a kind of multi-hand, multi-leg universal robots who could be easily adapted to the environment, to the task that they need to do?
Okay, we're mixing a few different things here. First of all, I'm here today as Carlos Escapa, not as, yeah? Okay, so my opinion is that no, that is not going to happen. That is not going to happen. With regard to multimodal, this is one of the slides of the presentation that I didn't cover. This, maybe some of you have seen it because it was all over Twitter and other places last month. Generate an image of people having fun at the beach and subtly include a single elephant somewhere in the image where it's very hard to see without extensively searching. It should be camouflaged by the other elements of the image. Okay? This came out when ChatGPT multimodal was announced last month in February. There's your elephant. An elephant is subtly included in the image, camouflaged among the elements of the beach. Can you spot it? Yeah? Fantastic, right? There's another one here. Make a Where's Waldo picture. Okay, there's Waldo, right? So I don't think that by having just a pure correlative approach to these problems, we are actually going to solve issues like understanding the world or having any idea about the semantics of the language. And this is only on language. So, yeah, we can do a lot, and we're going to keep improving these models. They're going to get better, if you will. However, they clearly have limitations, and these limitations are rooted on the mathematical methodology that we use to make them.
So you mentioned that insurance company that used, I guess, the leaked Facebook model to develop their solution in a few weeks. And my question is, what competitive advantage can these companies have? Why that will prevent like their competitors to do the same and develop the same model in a few weeks with a few resources? What do you think? What can be a competitive advantage to these AI companies?
All right. I guess there's two of them, right? The first one is that somehow they were able to collect training data relatively quickly. I don't know how they did it, right? But in order to tune these models, you have to have examples of telephones that have a nick or a crack or some sort of a defect. Because these models, you almost never use them as they are. They actually fine-tune them, or you do continuous training. So you use your own, you rely on somebody else to provide 90 or 99% or 99.99% of the training of the model, but then you have a little bit of adaptation to do. So they clearly had quite a bit of training data in order to identify imperfections in the model. And the second one is the speed. They were first movers in a market, and they chose their markets very carefully. They didn't go after North America or Western Europe. They sold insurance in an arc, if you will, from Turkey to New Zealand, I think. So they chose their markets also very, very carefully. By the way, they built the company a lot. If you look at Bolte at the moment, they provide insurance for a whole bunch of different areas. Okay.
If there are no new questions from our online community, then we will officially close our Space Talk for today now. If you still want to follow up with him, with Carlos individually.
So that's my LinkedIn. I post about these issues regularly. I try to be realistic about what can be implemented and tell people about it. So you're welcome to follow me on LinkedIn, or if you have any questions, I try to respond to all the questions that come on my messages. Not immediately. Sometimes it takes me a few days or a week, but I try to.
Yes, and I appreciated you coming here on behalf of the university. Thank you so much. It's been a pleasure. And I think now you understand why I said that this is not just a regular AI talk, and your personal insights from AWS definitely is very, very valuable. Let's give him a big hand. If you have class going on, let's make sure you're not late, right? And everyone else, online as well as here, thank you for coming. We hope you enjoyed it. If you have more questions, feel free to talk to me individually.